We developed a new type of printing, which is called impact printing. And it's basically a new type of additive manufacturing that's very different from both extrusion-based 3D printing, but also shotcrete-based additive manufacturing. And we shoot material very fast at high velocity to enable bonding between the parts. And we're using very cheap materials, no cement, and no chemical acceleration is required.
I was enjoying my life in Barcelona, very happily 3D printing earth houses. And there was always this question of, can this actually be commercialized and can this ever be cheaper than what exists on the market? You could 3D print only up to a certain height, let's say 30 centimeters to 40 centimeters. Then you have to wait for the material to gain strength, so wait at least for 24 hours. And then build on top. So when we printed a 2-meter tall wall in one session without taking any pauses, I think that was one of the moments that we thought that this definitely has a great competitive advantage over 3D printing, and this could have potential commercial applications.
And we can actually make luxury building products. We have different surface finishing methods, and then it becomes super interesting because it looks like a Moroccan tile or something very different. So then you can basically show that it can be acceptable to people as a modern building material, and therefore through modernization we also need to industrialize and make it a very fast industrialized process.
We tried addressing two major issues. I think one is of course using an extremely low impact material and construct with it. And the second one is how can you democratize construction? Because I think skilled labor is becoming scarce all around the world. And how can you democratize it? How can you increase efficiency and make it cost competitive so you don't have sustainable architecture which comes at an additional cost?
To save the world and make money at the same time.
Exactly. No, that's the hypothesis. You must make money to save the world. Otherwise, we won't save the world.
Welcome back to Constructive, everybody. Special episode. I got to visit these two in Switzerland. Now it's been a year, I believe, but really enjoyed getting to see you guys. Yeah, I think it was in winter this last year, right? In any case, really enjoyed getting to tour the facility and get to see some of the things you guys are doing. But go ahead and, Lauren, introduce yourself first, and then I'll do Kunal as well.
Okay, hello, everyone. I'm Dr. Lauren Vasey. My expertise is in robotic construction methods, and we've been based at the last 6 years, or I've been based the last 6 years at ETH Zurich. And the last 2 years, we've been developing or commercializing a new, more sustainable robotic printing method. And we just established a company, and we're super excited to talk about it on your podcast.
Sweet. Kunal?
Great. Hi, I'm Kunal. I'm originally from India, an architect who studied in an architecture school, which is extremely conventional, and then moved to Spain to learn about advanced manufacturing, robotic manufacturing. And about 8 months ago, I defended my PhD here at ETH in the domain of construction robotics. And together with Lauren, we are commercializing something we developed together for the past 5 years at ETH. And yeah, like Lauren mentioned, very excited to speak about it today.
Well, let's kind of Quentin Tarantino this, because I kind of want your whole backstory, but let's start with like what's happening now and what you're really excited about now, so we don't lose people's attention in case your backstory is boring. Just kidding.
Yeah.
But yeah, go ahead and tell me like the latest and greatest, what you're excited about sharing right now.
So we developed a new type of printing, which is called impact printing. And it's basically a new type of additive manufacturing that's very different from both extrusion-based 3D printing, but also, let's say, shotcrete-based additive manufacturing. And we, let's say, shoot material very fast at high velocity to enable bonding between the parts. And we're using very cheap materials, no cement, and no chemical acceleration is required. So we're aiming to basically enable, let's say, in situ resource additive manufacturing on a global scale.
Okay, let's preface this with what gave you the catalyst for this? Like, what was the big problem? What do you see in the industry that you're trying to solve? And maybe even we can go back a little bit. Where did this idea spark?
So when I arrived to ETH, there had been a new grant that was written about impact printing the concept on a small scale. The original concept, basically there was a little shooting mechanism with 5-gram parts, very small. And then basically the idea was to translate this into a full-scale manufacturing process. So with a bigger team, we wrote a grant on doing, let's say, a new additive manufacturing process that would drastically reduce the costs, especially compared to rammed earth, for excavated material-based production. And so the grant was written with a conceptual framework, but then we hadn't, let's say, started the work. And then eventually we hired Kunal because Kunal has been doing extrusion-based, earth-based manufacturing for several years at EAC. So he became a very interesting person to hire for the ETH grant once we got it awarded.
Yeah. So as Lauren mentioned, parallelly when the grant was written, I was enjoying my life in Barcelona, very happily 3D printing earth houses. And there was always this question of, can this actually be commercialized and can this ever be cheaper than what exists on the market? Because eventually I think it's an amazing research that has been happening also at Barcelona in the school, but I think we've never managed to cross the bridge and actually make it to the commercial side. So this was one of the, let's say, incentives for me as well to look into how ETH does stuff, which was kind of cool back in the days, or at least I thought. And then with the whole process, we tried addressing two major issues. I think one is, of course, using an extremely low impact material and construct with it. And the second one is, how can you democratize construction? Because I think skilled labor is becoming scarce all around the world. And how can you democratize it? How can you increase efficiency and make it cost competitive so you don't have sustainable architecture which comes at an additional cost?
Awesome. I want to dig into both of those things because I'm very interested, but haven't done tons of research about material science. I just love the idea of continuing to explore what kind of materials we use in this industry, because it feels like wood and steel and concrete for the past as long as we know. And I'm curious about that. Let's dig into that first. Like, did you guys do a lot of exploration of materials?
So I think that's super interesting in terms of cost, because I think that there was an inflection point at the point when steel became industrialized and when concrete became industrialized, where those two materials became much more lower cost, and especially the inversion also of the cost of labor. So I think actually it's more, the way we used to do things was with materials that were local, minimizing transportation distances, that had more manual labor steps, but you also had more skilled craftsmen or craftswomen who knew how to use those materials. And so at the point when those became industrialized, they lowered the costs. And once the big costs became lower, then they replaced a lot of, let's say, more sustainable local materials that were, let's say, aligned with a lot of, let's say, crafts-based, trades-based processes. So in a way, we're trying to establish those methods by industrializing the process for natural materials like excavated materials.
Talk about that. Like, this is, you guys, or my understanding is it's a sustainable material too. Was that intentional, or was it also like, we need a certain kind of material to shoot it? I'm curious about both of those things.
It was also always motivated as a earth-based, like, alternative to rammed earth construction. But then what we developed could be extended to other materials.
Yeah, no, I just wanted to echo on the same point. I think it was always since the beginning that we would use earth-based materials. I think they're extremely non-standard. I think they change from, let's say, if you excavate it from site or 10 meters away, the composition changes, the granulometry changes. But I think the process that we develop can handle a lot of tolerances that come from the material side as well. And then, let's say, throughout the last 5 years, when we developed the whole process at ETH, we worked with earth-based materials. Of course, they were coming from the same site, but different, let's say, depths. So we had to somehow adjust them, but they're always, let's say, majority, they are based from earthen materials.
Cool. Let's get into the robotics of it, if you don't mind. Can you explain to, maybe there's people, I'm going to try to pull some video, or I might hit you up because I do have some. I'll have to find it, but I'll hit you up maybe for some visuals so that while we're talking about this, I can overlay that. But do you want to kind of explain what your robotics are doing?
Yeah, so we basically developed a method for high payload robotic platforms. High payload just means how much weight the robot can move and execute a construction task accurately. So we, instead of developing a kind of optimized low payload tool, we developed a huge tool that's 250 to 300 kg payload, and we developed it to integrate on multiple types of platforms. So the whole concept behind the grant was that we would develop a tool that could move from a prefabrication construction scenario, like a factory-based scenario with industrial robots, but then basically move on site to the construction site and also be integrated on autonomous construction equipment, such as an autonomous gantry machine. So we basically have a custom tool that basically extrudes and shoots material.
Awesome. What do you think was the moment, and maybe we can dig into the research side of it too before this kind of became a company, but I'm just curious when it was like, okay, we're studying some things. Now, this needs to be a company. We need to take this to market. And what was that point?
Yeah. So typically, when you work with earth for construction, you mix it with water, it becomes soft, and then you can use it to either plaster or to make bricks. And then it gains strength by evaporation. So generally, there's a limit that the earth can withstand its self weights. At least when we were 3D printing back in Barcelona, you could 3D print only up to a certain height, let's say 30 centimeters to 40 centimeters. Then you have to wait for the material to gain strength. So wait at least for 24 hours and then build on top. So when we printed a 2 meter tall wall in one session without taking any pauses, I think that was one of the moments that we thought that this definitely has a great competitive advantage over 3D printing, and this could have potential commercial applications. And then that's how, let's say, the conversation started began.
And do you think, I'm curious about scale. What are the limitations? And do you even know yet? Can we build a skyscraper like this?
No, I think the limitations are that we can achieve now between 2 to 6 megapascal, but as a compressive strength. But as we said before, we're not constrained to that material mix. We can try other binders, other additives, so we potentially could build up much higher. But that would basically enable several stories of buildup. Could we get something like 10, 20, 30 megapascal like concrete? You can always stabilize with cement, but there's always a trade-off with basically the LCA embodied emissions. So I think there it's more about developing a mix design so that it's very specific to the application. But I think there's the limits are on strength, compressive strength, but also on speed. I think we haven't seen the speed limit because we don't have this huge constraint that comes in 3D printing where you have to basically have the build rate correlate to the compressive green strength development. So there, I think we have a huge advantage in terms of eventually being super fast from a construction point of view in terms of volume per time.
And then, like, decarbonization, I imagine, is part of this too. Can you talk about the sustainability of using earth materials a little bit more?
So currently with the mix that we use, we are not stabilizing it, or we do not use any cement. And what we are developing as a first product is that we use earth-based materials and then we encapsulate that in a timber frame. So we can be modular and it can be transported easily. And so when we don't use any, let's say, chemicals to accelerate the material to gain strength, I think it becomes 100% recyclable. It can be, so this is one of the major, let's say, reasons that it can be low cost, and it can also be impact. And this can be sourced in very different parts of the world, right? So it's also scalable in that case, that the sustainability aspect or the low carbon aspect is kind of scalable.
This might be a silly question, forgive me, but like, I just imagine mixing something messy and natural like dirt with a robot. That's an interesting hybrid. Can you talk about like anything you came across because of that combination?
I mean, I think it's a little bit high tech, low tech. And the question is it not really making sense because earth-based materials should be done manually in certain situations? But we believe actually earth-based materials can be industrialized, and we can actually make luxury building products. We have different surface finishing methods, and then it becomes super interesting because it looks like a Moroccan tile or something very different. So then you can basically show that it can be acceptable to people as a modern building material, and therefore through modernization we also need to industrialize and make it a very fast industrialized process.
And is it giving, like, do you imagine this will give more design freedom? Does it allow for shapes and structural elements, performance that maybe other traditional materials didn't?
I would say maybe for the general audience, the best way to understand this would be that it's, let's say, rammed earth without the formwork. So you do have all the possibilities to have a strong interlayer bonding, but you don't need a formwork, so you can, let's say, make curvilinear shapes. In terms of design, I think the material also allows it to be, let's say, to allow a certain kind of design freedom, because you can integrate a lot of other subsystems like what we do with the timber frames. I think this opens up a lot of possibilities that you can also integrate doors, windows, services very easily when the material hasn't gained full strength. And this is maybe one of the ways of also understanding design freedom.
I think I've seen one or both of you guys post or talk about the human factor of this, like the perception of robots maybe in the field on construction. Do you have thoughts about how this will interact with the people building stuff?
I think it's more about a shift in the nature of work. When automation has taken over other industries, basically it's created new jobs for, let's say people controlling manufacturing units on through user interfaces. So we don't see it as, let's say, something that's going to replace labor, but more replace repetitive, dull, dirty, dangerous tasks. I think our system is super high payload, so it's, let's say, not a situation where you'd have a person, let's say, interacting very closely from a safety perspective. But I think we imagine more kind of like smart trade-offs between robots and manual workers, either in the factory or on the construction site. Just kind of with a digital kind of oversight from a planning perspective and dispatching.
What do you guys imagine it would be like? Let's just say ImpactBuild takes off and takes over the world. What is a city going to look like in 2040 if it's built by you guys?
No, go for it. Go for it.
Oh, yeah, sorry, we were going alternating.
It's good.
No, I think now we know that our method has an advantage in a lot of areas globally. It really makes sense when you have really extreme temperature variations from day to night, because then you have the possibility to do basically passive heating and cooling through just thermal inertia. So it's certainly optimized for climates, which it's a huge percentage of the world, but it's not everywhere. But you can still combine, let's say, thermal inertia materials like earth with insulation materials. So I think right now we've done different visualizations of architecture that can be produced. With our method, it really makes sense in quite a lot of different climates. But then we also envision ImpactBuild more broadly, where we can actually just start industrializing materials that are low carbon, but also scalable. And we basically develop more efficient industrialized processes to, let's say, vary the typologies to also make them cost competitive with carbon intensive solutions like cement and, let's say, cementitious fired brick and mortar.
Cool. We can come back to ImpactBuild, but I'll start with Kunal. I'd love to just hear your motivation. Like, what made you interested in the construction industry or researching robotics or material science? What was the spark there? Were you pretty young when you discovered you were into this stuff? You were a nerd about this stuff?
I think the interest to architecture was maybe the city I grew up in. We had one of the, let's say, a very good design school in the same city, so I could get into architecture. We practically lived inside the building, so it was a lot of, let's say, hands-on experience. We had a carpentry workshop. We had a lot of things that we could do through, let's say, model making. We were not allowed to use computers until until 4 years out of our 5 years. So you can imagine that I love making still. And then I happened to go to Barcelona, where I learned how to program machines to do, let's say, to transfer skills that we have from like all of our tacit knowledge to something that can be mechanized and used at scale. So I think I still enjoy doing this. Even at ImpactBuild, we still have a lot of processes that we develop, that we tested out, and then we can, let's say, incrementally automate, and to the point that we can use it in the process to enhance efficiency. So I still very much love making, and I think this maybe comes from the way I grew up. But yeah, I think impact printing in that case is like really, let's say, hardware focused as well. We do have software aspects, but you can see that it's really driven by hardware innovation.
I do think, though, you have to kind of develop a love for the construction, architecture, engineering space to stay in it, because it's not quick to innovate. I wonder if you have stories about that, like being an innovative, creative person in this industry. I'm sure there are hurdles. How do you stay motivated to not give up on this particular industry?
It's for me, right?
Yeah.
Yeah. Okay. No. Yeah, I do feel that there are hurdles, of course, but you do see that if we continue working the way we have been doing for the last, 100 years, we wouldn't have all of these problems. I think we are also situated in a very good environment. It's a very good bubble where there's a lot of innovation happening around us. It's not just us. There's a lot of other people as well working on very cool stuff around. So I don't think we have to look far away for motivation, let's say.
Yeah. Okay, Lauren, I want to hear your backstory too. American, right? Initially. So I want to hear like how you ended up in Switzerland too, because I think you told me before, but I already forget.
Yeah. So I, let's say when I was young, I was more like into mathematics, but I was always creative. So I was always like making jewelry or doing, playing with Legos when I was really young, those kinds of things, and getting like really obsessed with creative projects. And when I was in college, I declared engineering as a major and civil engineering to start, even though I was also taking a lot of more general classes, also with, let's say, VB and different programming languages to solve engineering problems. But eventually, because I got obsessed with some of my CAD and CAM engineering classes, then they kind of pushed me to do civil engineering and eventually maybe to think about a hybrid between civil engineering and architecture. And so then I decided, after I got my civil engineering kind of general engineering degree, to do a master's where I was going to do a structural engineering master's and an architecture master's. And I went to University of Michigan at that time, which was developing this huge robotic fabrication lab. And I took the robotic course with someone who's very famous in this field, Wes McGee, and I loved the course, and I already started working with them after I finished, like developing basically code for some of the robotic processes there. And then I decided I want to specialize in, let's say, robotic fabrication for construction. And when I graduated from Michigan, then I decided Michigan had the best facilities at that moment in the US for what we do, let's say robotic construction. And so then I already knew that the best unis were ETH, but also Uni Stuttgart. So then I applied to open calls for PhD positions, and I ended up coming to ETH for a short, let's say, research position. But then I did my PhD in Stuttgart, and then I came back to ETH for my postdoc, which is when the impact printing process started, or the research project.
Yeah,
it was very long.
No, that's great. Thank you. And I know there's a lot of cool stuff happening there at ETH. Do you want to highlight any of it or tell people? Because it's not just you guys working there. It's an exciting place to be, I assume.
Yeah, I think ETH was one of the first institutes, and I think it has this NCCR, which is interdisciplinary, combining a lot of different disciplines, doing, let's say, full-scale robotic manufacturing, involving, really good roboticists and material scientists and concrete engineers. I think now ETH was a beacon, let's say 10 years ago, but now it's very exciting because you're seeing a lot of other institutes, let's say, repeating the formula of the interdisciplinary research. Yeah, I think ETH is having access to unbelievable resources from the perspective of experts in every domain. So this is a huge, let's say, benefit. But then, yeah, I think when I was at Stuttgart, it was a little different because it was more like a lot of generalists and a lot of creative problem solvers, like Kunal was saying, a lot of people loving prototyping. And you can also have innovation when you have people that are not domain experts, but just super generalists and super creative. Whereas ETH, the model is, let's say, domain experts and interdisciplinary collaboration. So I think you can innovate with both kind of types.
Yeah. Kunal, are you guys piloting yet? And do you have any case studies, things to share already? I know it's early.
Yeah. So I think the way we are operating is that we are acting as a subcontractor for the local market. So we will be delivering a pilot project, which is a big facade wall in Enpa, which is very close from Zurich, in Dubendorf, where we do a facade, let's say, wall with a lot of earth and timber hybrid, let's say, panels. And what we would try is to use different materials there. So we see how it weathers, how does it respond to external factors such as rain, such as wind and snow in Switzerland. And then the second way that we are acting is that we are franchising, leasing and selling our microfactory units. So we recently had some very good, let's say, requests from India, where we might be doing our first pilot by the mid of next year, where we incorporate one of the microfactories, and we'll pilot for 18 months to make 5 villas there. They are resorts, and they have a huge, let's say, stock of excavated material that they have absolutely no clue what to do with. And that's how the idea started, that, okay, we could just come there and we can deliver this project in less time than what you can imagine. So these are the 2 pilots that we are currently working on, and they are extremely exciting because they are very different in nature. I think there's a lot for us to learn there as well. But yeah, currently these are the 2 main pilots.
Yeah, I know we touched on it, but you just made me think about how this really does feel like the cradle to grave concept, where it's like, I bet the reversibility of this potentially is really good too, where it's like you're talking about India having a lot of material that they're like, we excavated this and now it's just sitting there somewhere. Well, we can not only reduce that waste, but then once we build something, it will be potentially easy to recycle too. Lauren, do you want to flesh that out even more than I just did? Sorry.
Yeah, exactly. I think we reduce the consumption of rare resources by using, let's say, local excavated material. So it's smart reduction, but also recyclable. But it's very tricky because sometimes earth based manufacturing processes look sustainable, but they're not actually. It really depends on how many additives you add. So we actually have to be very careful because if you stabilize with a lot of accelerators like a lime or a cement, then you can end up still being, let's say, you can recrush it, but you won't actually be able to have the same material properties when you rebuild with it. So I think with sustainability, we try to be, really executing and doing the cradle to gate LCA analysis, but also to double check that if you use additives, you're not jeopardizing the true recyclability.
So cool. I just want to let you guys plug whatever you want. Where should people go to learn more, or what do you guys want people to do after hearing this?
I mean, we really want excited clients or people that want to work with us and integrate our system. So this could be anyone from a prefabrication company to other earth-based manufacturing companies. We basically want to, let's say, work together. We believe that we have huge, let's say, not only profit margins, but also huge, let's say, sustainability benefits. So that means that anyone who partners with us, we're trying to, let's say, decrease the huge market share of materials that are bad for the environment. So we're super happy if people directly reach out to us, whether they want to license our machine, do a project with us. Yeah, all of the above.
So save the world and make money at the same time.
Exactly. No, that's the hypothesis. You must make money to save the world. Otherwise, we won't save the world.
And find Kunal too, where I assume LinkedIn is an okay place for people to find you, and we can link some stuff in the description here. But thanks for coming on, guys. Hopefully in another year we'll do another follow-up and see how amazing you guys have done.
Absolutely. Thank you so much for your time as well. This was really nice.
Yeah. Thank you.